Hello everyone, welcome you all to the lecture 4 of the DSS series with Java. Today we will be discussing the very simple and strong problems in the programming. These programs are looks very simple, but there is lot of mathematics and logics is working behind these problems. So if you solve this problem, you can see lot of similar problems, those working on these similar logics and similar mathematical operations. And before that, we should definitely know the how we should solve the problems. Let's say, so these are the tips you should definitely follow before solving any problem. The first tip is that read and understand the problem. I will be explaining the each tip using the example here. I took the one question here. The question is asking that sum of first n odd numbers. I think you definitely got the question here, right? It is simple that you need to find the sum of the first n odd numbers. And second tip is understand the inputs and outputs clearly. Let's write the input for this problem. The input for the problem is, let's say I'm taking ns, like um I want to find these first five, some of the first five odd numbers, right? Let's write the simple natural number series here: 1 2 3 4 5 6 7 8 9 10, right? You can see the question is asking that first five odd numbers, sum of the first five odd numbers. By seeing this series, you can simply say that this is an odd first odd number, second odd number, this is third odd number, this is the fourth odd number, this is the fifth odd number. So the output of this for the n is equal to 5 should be 1 plus 3 plus 5 plus 7 plus 9. I think it would be 1 plus 4, 1 plus 3, 4, 4 plus 5, 9, 9 plus 7, that is 16, 16 plus 9, 25, right? For the n is equal to 5, the output should be 25. So we will be taking another test case so that we can have some clarification about the question here. I will be taking n is equal to 6 here. I don't want to write the series again, so I just extending this series like 11, 12, right? You can see this is the fifth odd number and this is the sixth odd number. So up to fifth odd number, you found that this is the total sum you got from the this series, right? So if I will be adding, like, sum should be like something 25 plus the sixth odd number is 11, that should be 11, that would be giving me 36. So for n is equal to 6, we are getting the sum as 36. That is actually saying that the first n or some of the first n odd numbers. So the second tip is understand the inputs and outputs clearly. We saw that the inputs are like n is single integer n, that is only one input we are getting, and output should be a single integer, that is printing the sum as 25. And the third one is dry run the sample test case. We already done that. For n is equal to 5, we wrote this complete series here to demonstrate the how the odd numbers we are taking from the series. And we already done the dry run for the sample test case here. So this is the fourth tip, is the very important tip in the programming. Like, this will take some time to build the logical steps in this while solving the problem. Initially it will take time. By solving the problems or practicing the more problems, you will definitely find it will take less time to solve any problem. Let's see, this is the most important part of the solving problem, building the logic. It will take more time because, let's see, by seeing this series, you are definitely easily finding that this is an odd number, this is an odd, 3 is an odd number, 5 is an odd number. But it's very difficult to computer by visualizing, right? It can only understand by writing some logics inside the program. So you are telling that telling to the computer that it is an odd number, you can simply add it to the sum of the sum is a variable, right? So this is how you need to definitely make computer to understand this, how your logic will go into work. And before that, you need to know the what is an odd number here. In previous lecture, we have seen that the number let's say number is 2, and when I am doing some modulo 2 is equal to 0, so I would be definitely say that it is an even number, else I would say that it's an odd number. What is the other case? So other case is definitely like some number is modulo 2 is equal to 1. If it is giving remainder 2, if it is not an even number, it definitely would be odd number, right? if it is if it will be giving me remainder as 1, then it is an odd number. So you should definitely know this thing, or you can do another thing in this. I will be teaching the both the logics here. So let's see what write a pseudocode and dry run again. We will be writing some pseudocode here. Let's say in the by seeing the series, we are not making any relation with the n and the series, right? For n is equal to 5, we are traversing up to this 9. So we found that there is an fifth number is found, odd number is 9. So we don't find any relation between the n is equal to 5 and the last digit you actually want to travel, you actually want to traverse here. But how we can traverse up to the particular digits? So when the situation is comes like you don't know the how, at what point you need to stop the iterations, and you don't know the actual how many iteration you need to do. So in such particular situations, you need to follow the, like, you need to use the while loops here. So when you already know the how many iteration you need to do and how many, like, um, what is the value that you can have at last, you already know in the prior in before, you can use the for loop. But here when you are seeing n is equal to 5, you are not making any relation with the 9. This is the last iteration, you last digit you need to iterate. But for in those cases, we need to definitely use a while loop. So inside the while loop, let's see how we can do this. Let's write the series once here. So the series is for n is equal to 5. I'm dry run for the n is equal to 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here I don't know how many iterations I can do. I don't know the what is the actual value that I can go at last. In this case, I am using the while loop. Initially, I will be here. Then I need to go for here. Then I need to go for here. Then I need to go for 7. Then I need to go to 9. I need to stop here, right? What I can do is I will be maintain um, some variable as count, right? Initially, I will be starting from the I is equal to 1, right? So 0 is an even number. We don't want to traverse from that. I will be starting from 1. Let's see, I'm checking that the particular I is odd. Yes, it is an odd. I will be simply increasing my count. Let's wait for a minute. I will be writing the count here because I can write. Let's say I am standing at I is equal to 1. I am marked it count has increased to 1, right? When I am going for the I is equal to 2, I am coming to here. I will be simply checking that is an odd or even. You saw that this is one is an odd. You can see this is an even number, right? You don't want to increase the what? You don't need to increase the count here. You can simply put. When you go for the I is equal to 3, you saw that this is an odd number. By checking the condition, you are simply increased your count to the 2. So we want the count should be the number of odd numbers should be 5, right? We want 5 numbers. Let's go for the I is equal to 4. This is even. We don't increase the count here. We'll keep the counts same. For I is equal to 5, we will be having, like, this is an odd number. The count should be get increased by, no, this is 2. Count get increased to 3, right? In next iteration, you can see I is equal to, see, this is an even. The count is same. For the I is equal to 7, you can see this is an odd number. The count is getting increased to the 4, right? For the I is equal to 8, it is an even number. The count is same. We don't want to increase. For I is equal to 9, it is an odd number. Count is 5. We found that 5 odd numbers is already completed. So we need to stop our iteration at this place, that is I is equal to 9. How should we write the condition if in while block? So while is running until the condition is not true, not false, right? If the condition it get false, the while loop gets stopped there. And you can see this is how iteration will go on. We will be starting like I is equal to 1. Let's write something pseudocode here. I will be writing pseudocode here. I will be writing something like yeah, pseudocode. Initially I will be initializing, I will be starting from I is equal to 1, and I will be marking the count is equal to 0. Initially I don't have any odd numbers. So I will be using while loop because I don't know the actual iterations I can do before writing the program here. If you know the exact iterations before writing the logic, before executing the program, you can use the for loop here. But I don't know the exact iterations am doing here, and I can't relate anything with the n is equal to 5 here, because that's why I'm using while loop here. Every time I am increasing I plus, this is a post increment. What is the condition we are in every alternate iterations? You are checking odd or even, right? So what I can keep is condition is if um, I I is odd. What you can do? We want sum of the numbers, right? We are not added any the numbers. We are just counted the odd numbers here. What I can do is I can simply maintain one of the variable as sum is equal to 0, which is taking my sum as sum plus is equal to I. So if the number is odd, I will be simply putting the odd number into my sum variable. It will be taking all the sum of the first and odd numbers. You can see when this condition executed, sum will having like something one. When this condition is executed, the if condition only executed when the odd number is odd, then only we are adding the particular I, right? So in this you can see already sum is having 1. Here 1 plus you will be having 3, right? That is 4. We will be having sum is equal to, already it is having 4, 4 plus 5, and it will be only executing in the odd cases, right? It will be having 9, 9 plus 7, that is 16. It is sum plus is equal to 16 plus 9. So 1, 2, 3, 4. There, there were 5 cases that sum will be getting updated here. So this is then pseudocode which is look like when we should stop our while loop here. You can see you need to definitely stop here because you got the what expected number of odd numbers here. We want 5 odd numbers we found here. So how should we keep that? Let's and we need to increment the count when we found the odd number here, right? So let's I will be writing this into I want to also increment the count of odd number, count plus. So when the count is, let's say, less than 5, right? Less than or equal to 5, until I need to run these loops. If the count will get what the count will exceed the 5, let's say count is 6, then I need to definitely stop that, right? So this is how the program will look like. There is another way of writing the same logic here. We will be see we will be writing the code for this logic here. So the problem is sum of first n odd numbers, right? What I can keep is, let's say I'm taking n is as 5 as I dry run on this test case, and I will be maintaining into count to track how many odd numbers I have seen in each iterations, and I will be starting from int I is equal to 1, right? While count is less than or equal to 5, I will be run my program. In each case I need to check that I modulo 2 is equal to 1. That will be checking that is the particular number which you are present is odd or even. I will be doing something like I need to declare one of the variable into sum is equal to 0. I will be simply adding some place is equal to I, right? and I will be incrementing my odd count. After that, every time I need to increment the I here, because I is a natural number which is traversing from the 1. We will be simply printing out the sum of the first n odd numbers. That would be like sum here. Let's see the output of the code. Yeah, we are running the another. We need to run the current file here. Let's see. You can see 36, right? We got the correct output. So there is another way of solving the same problem. Like every time you can see from here, you are jumping from to here, right? From 2, you are jumping to the 3. Not 2. Oh, sorry. I will be right. Yeah, you can see here. From 1, you are jumping to the 3. From 3, you are jumping to the 5. From 5, you are jumping to the 7. From 7, you are jumping to the 9 here. What you can do is every time you are jumping like I plus I is equal, initially I is equal to 1, next is I is equal to 3, next is I is equal to 5. It means that every time you are jumping like 2 steps forward, right? Yes, I want to write. So what would be a condition every time initialize I is equal to 1 and you need to jump I is equal to 2, every time you need to jump 2 times. So how many times you can jump, like this is the first time, this is the first time, this is the second time, this is the third time, this is the fourth time. So you are actually jumping like 1, 2, 3, 4, 5 times, right? So there would be 5 possible places you are actually um, adding into your sum. Let's see, I will be simply removing this all this variable, like I don't need the count here. What I can do is I will be simply adding some plus is equal to I, and while what I can keep is that like while n is greater than 0, right? Every time I am decrementing n, so I need to have n iterations, like 5 iterations. So I need to update the I is equal to 2 every time I will be jumping to the 2 steps forward. Let's see, does we getting same output, or yeah, we are getting some wrong output. Let's see, try run this test case. Initially you are standing at the I is equal to 1, you are adding it to your answer. In the next case, yeah, n is greater than equal to 0. Yeah, we are getting right answer. So we are not let's see how it will be working. You can see initially you are standing at this is an one iteration, this is a second iteration, this is a third iteration, this is the fourth iteration, this is the fifth iteration. For n is equal to 5, you are doing 5 iterations, right? So what I am doing is initially n is equal to 5. In every iteration I will simply subtracting the each iteration from this one. If you complete the first iteration, subtract the one iteration from the n, you are left with n is equal to 4. Again subtract 1, you are left with the 3 iteration. Again subtract 1, you will get left with the another 2 iterations. Like for n is equal to 2 minus 1. Again n is equal to 1, 1 minus 1. You are left with the 0, right? So until we are not reaching 0, we definitely need to process all the iterations. In each iteration, you are standing at this position, you are simply jumping 2 positions forward and adding this value. Again, you are jumping to this value, you are adding this value. Again, you are jumping to this value, you are adding this value. So this is how the flow program is working. Yeah, we are done with the all the tips, and we should definitely. I think you all got how we can follow the tips. So these are very important. Let's see the. I think we need to discuss all these problems. And next, the problem is check number is even and odd. I think I almost explained this problem in the previous problem. So it is very simple that the particular is even or odd by the basic mathematics. We all know that how to check the number is even or odd. Let's say number is 6. If the number is, let's say I'm doing the division here, like 2 3 the 6, you are getting remainder 0. If the remainder is 0, then you can definitely confirm that this number is an even number. Let's try for the sum of the some odd number. Like I'm taking number is equal to 7 here. If you divide this number with the 2, like how many times you can divide the 7? Like 2 3 the 6 times. If you take 4, 2 into 4, that would be giving 8. This is not possible, right? 2 3 the 6, you are remained with the one number. You can see we are getting remainder 1. So we can confirm that this is an odd number. So this is a very simple basic logic. So we can use if else condition very simply, like if number is modulo 2 is equal to 0, we can say it is an even number. Else we can say it is an odd number. If the number is an not even number, it would be definitely like odd number. Let's write in pseudocode. Let's write the code. Odd, or let's, I will be taking number as like 7. If number is divisible by 2 and giving remainder 0, then I would be printing that it even number. Else I can print that if it is a not an even number, it would be like odd number definitely. So here we are only working on the two conditions, right? So that's why we are using if else. You can see I will be commenting out in this one. Let's run this program. You can definitely see the 7 is an odd number. Now we will be discussing the second problem. The second problem is find the last digit and the remove last digit of a number. So the logic working in this problem is very important. You will be frequently see in future in lot of problems. Let's say I will be having number as n is equal to 1 2 3. So last digit of the number is 3, right? And if you remove the last digit of a number, you are left with the n is equal to 12. How should we achieve this one? Let's say it will be, let's write the 1 2 3 as in the expanded form, like 1 into 100 plus 2 into 10 plus 3 into 1, right? So this is the expanded form of this 1 to 3. And if you can see here, if you want to get this number, what you can do, you are shifting this number into the left side, right? It's just you are removing the, let's say this can be written as 1 into 10 power 2 plus 2 into 10 power 1 and 3 into 10 power 0. So if you write this expanded form of the 12, you can see 1 into 10 plus um, 2 into 10 power 0 and it is 10 power 1. You can clearly observe that we are remove the power 1 of the 10th power, right? You can see here we have 10 power 2, but we are only have like 10 power 1. So we are removed the 1 of the 10th power. So this is how the logic working behind the this problem. And you can see when you are taking 10 as a common from this all this element, you can left with 1 into 10 plus 2 into 10 power 0 plus 3 by 10, right? So when you are taking 10 as common, you are left with these numbers. You can simply see here that when you are doing 3 by 10 here, you will definitely get 0, right? So at the last you can see 10 and 1 into 10 10 plus and 2 into 10 power 0, it will be giving 1 and 2 into 1 1 2 into 1 2. You can see at the last we are left with 10 into 12 here. So how should I remove the 10? I want only 12 as a result, right? What I can do is I will be writing here. So this is the how derivation, how we can removing the last digit. We are at the last we are left with the 10 into 12. So this is the result actually we want, but we don't want this 10. What we can do is simply divide with 10. We are remove this one and we are left with 12. So at the last, the final observation would be like when you have when you want to remove the last digit, you are simply doing n by 10 here. So this is the simple logic. How this logic is working, we all see in using the mathematical derivation here. N by 10. This removes the last digit, right? Removes the last digit. Let's say if I want to last digit, you don't want to remove the last digit, but you want the last digit. I will be erasing it out. Let's say this is a number 1 2 3. I want the last this digit. What I can do is I can definitely, let's see, if I will be doing modulo with 10. Let's say you are left with 3. So the idea to get the last digit is you are doing modulo with the 10. So n modulo 10, it would be definitely giving you the last digit. So this is the logic for to get the last digit. So these are the standard logics you definitely need to remember, and you need to know how the what mathematics working behind these logics. So we, so how should we write into the program? So if you ask to find the last digit and remove last digit, it is very simple. So I will be writing some pseudocode here. So I will be definitely storing this result into the integer only. Let's say I will be giving 1 2 3 4 as a number, and I want the last digit int. But I can do last digit storing in the integer. I will be doing something like 1 2 3 4 divided by 10. This will be giving the last digit. If I want to be not last, sorry, just not giving last digit, would be removing last digit, right? remove Remove digit. I will be taking remove digit here, and I will, this is last digit. So when you are doing modulo of the any n number, let's say n modulo 10, this would be giving you the last digit, right? So this is the simple two line code that we will get. Like, let's write the code here. Say int number is equal to 1 2 3 4. So what I am doing, I will be into into result is equal to, not result, uh, remove digit is equal to number divided by 10 into remove, not remove, I will be on last digit is equal to number modulo 10. Sorry, for modulo 10 s out, remove digits, remove digit, right? So the expected output should be like 1 2 3 4 and 4 last digit. It would be giving the last digit. By doing we are doing modulo means we will definitely giving the last digit. And if you are removing last digit means you will be like getting like 1 2 3. Let's run this program first. You can see that we are getting expected output. Yeah, we are done with this one. Let's move to the next question. So these are the standard logics you definitely know. and count the number of digits in the number. So this is an similar logics in the as we discussed in the previous question, but we need to extend similar some of the more concepts in this question. Let's say I will be giving you as n is equal to 1 2 3 4, right? So your job is to count the number of digits. Count the number of digits. So you can see here that number of digits are 1 2 3 4. So you got the 4. How should we do? If you think little about the previous logics, you can definitely get the how we can count the number of digits here. Initially, we will be, let's say, 1 2 3 4. I will be applying here removing logic here. Initially, I will be removing 4 here. I will be left with 1 2 3. Again, I will be removing 3 here. Again, I will be getting 1 2. If I will be removing 2 here, I will be getting 1. If I will be removing 1, I will be get 0 digit, no digits left. How many iterations I have did there? Initially, this is the first iteration, this is the second iteration, this is the third iteration, this is the fourth iteration. Each time I am dividing with the 10. So in each time I will be simply taking, have you seen in the previous slide? You can see. So this is how we are, each time we are removing the power of 10 from the digit. So that would be definitely shifting our number to the left side. So we are shrinking the number here, right? So this is a simple logic how we can apply into the code. Let's say you are having 1 2 3 4. What you are doing here? I will be I will be writing it very clearly in the beside this slide. Let's wait. You can see I will be having n is equal to 1 2 3 4. In previous logic, you remember that if you want to remove the 4 here, what you are doing here? Let's say I'm writing 1 2 3 4. If you want to remove the 4, I will be doing 1 2 3 4 divided by 10. I already explained how this working, and in the result you are getting 1 2 3, right? Again, I am having 1 2 3 as a result. What I am doing, 1 2 3 divided by 10. What is the result? 1 2, right? 1 2. If I will be divided with 10, I will be left with the 1 here. And the next iteration, you are left with 1 by 10. You got 0. So when you need to stop here, when you get the value as a 0, you need to terminate our program in here, right? I already told you that if you don't know what is the exact number of iterations you are doing, you need to definitely use a while loop. So here we don't know the exact iterations. Let's say there's some in future you might find that the number might be like very big, like having like 30 digits. So it's very difficult to find the number of iterations. In this case, every time what you are doing, you are every time you are doing n is equal to n by 10. This is an code that is running every time, and this I think this is only one thing we are running in this. This is a core logic we are doing. What I can do is I will be running while loop here. I don't know the condition here. Every time I will be simply doing n is equal to n by 10. I'm just updating n here, right? You can see I am taking one n here, I will be taking one here, I will be taking one here. So this is the logic, and simply what I can do is I can maintain count that will count the number of digits in my number. That would be, I will be incrementing count plus here. What could be the terminating condition that I should keep here? What I can keep is while the number is greater than 0, I can go on doing this operation, right? If at any case I found the number is less than or equal to 0, I would definitely stop the iteration. Let's say what I can write is while number is greater than 0, let's say 1 2 3 4, I will try running this. Initially I will be having 1 2 3 4, the number is greater than 0, I will be simply doing this and I will be getting result in the next iteration. Iteration number 1, in the next iteration I will be checking 1 2 3, are you greater than 0? Yes, it is in greater than 0. Performing the operation, incrementing the count, got 1 2. In the next iteration you can found there is a number 12 which is greater than 0, doing the same operation. in the next iteration found 1 which is greater than 0. Doing operation at the last, you found that number n is reached to the 0 which is terminating here. And you can simply see that this is how we can count the number of digits in a given number. Let's code it up. Count number of digits. What I can keep into, I will keep my count as a, that will be tracking the number of digits. Let's, I will be taking, my number has to be 1 2 3 4, and I will do until my number is not less than 0. I will run my while loop while my number is greater than 0. If at any case my number reaches to 0 or less than 0, I will definitely terminate my loop. In each iteration, what I am doing is I will simply dividing with number by 10, which is removing the digit from last digit from the given number. Simply I will be incrementing my count. What I can do is I will simply printing the count here. You can see output of the test, output of the code here. Yeah, it's giving right. Let's see for the another question, largest of two numbers. It's very simple. You are given a is equal to 5, b is equal to 7. You need to find the largest of the two number. So you can see there are only two numbers here. We are using if, what I'm writing is, if a is greater than b, then which one is the largest? A is largest, else it should be definitely like 7 is the largest, or 7 is the equal to the a, right? 7, b is the largest. Let's say I will be having, in this case you can simply say that, yeah, 5 is greater than 7, it's not. So 7 is the largest, 5, 7 is greater than 5. So it is working like, let's say if I will be having number like a is equal to 5, b is equal to 7, b is equal to 5, both are same. So this condition doesn't work because it's a should be strictly greater than b, right? So it's not like that. 5 is not strictly greater than 5, so it doesn't work here. It will be working like, it will be saying that b is the largest, but it's not like that. So both are equal. So we will be adding another condition that will be checking that, so if you want to add something like, if you also want to check the numbers are equal or not, both numbers, that you can add using the else if here. And you can check that if um, a is less than b, then b should be the largest right here. Else the numbers are equal numbers, right? If the both conditions are not possible, so if you have these two numbers, these two condition will get failed, and this condition will be get executed, else condition. A is greater than b, false. A is less than b, false. Then it would be definitely executed. But here we are only we want to know that which number is greater here. We don't want to check that equal or not. So let's code it up here. A and b. Let's take int a is equal to 5, b is equal to something like 10, and if a is greater than b, then s out a here. What I will be, largest number is a. Okay, else what I can write is out largest number is b here. Yeah, it should definitely giving the output as 10 here. You can definitely see our largest number is 10. So we are good to go. So these are basic problems which are definitely help to solve the problems, and initially you need to definitely solve the easy problem that will give you more confidence. So yeah, this, I think this problem we already discussed it in the first slide. So this is a similar problem. to the that odd numbers in the previous one. Can So I will be just giving you the overview of the problem. Let's say I will be having input as n is equal to 4, right? 1 2 3 4 5 6 7 8 9 10. So first n even natural number. Let's see the what are the natural numbers here. So this is a natural number, this is a natural number, this is a natural number, this is an not sorry, this is an even number. So this is an even number, 2 4 6 8. So it's very easy to find even numbers. Yeah, we want the sum. It's very easy, like 2 plus 6 plus 8. What you are doing? You're just simply looping from the 1, right? And you are simply checking for each I. Is it I will be looping I from the 1, and I will be going on until I will be not finding, I will be not having numbers less than 4, and I will be simply adding the result into my answer. Yeah, we are left with 4, sorry. Yeah, it could be the output, like 2 plus 4 6 12 20. Yeah. How this is similar logic as we discussed in the problem in slide 1, right? So this is same as this slide, similar logic based on this. I think I have wrote pseudocode also. I think I don't want to discuss more about this. You can try it yourself. It's very easy. Or I can write a pseudocode here. Let's say here also you can see. I think this is very like you are simply going here. You are sorry. Yeah, you are going 4, 6, 8. Every time you are simply jumping to two places, right? So let's say n is equal to 4 means you are started from here, and this is the first iteration, second iteration, third iteration, fourth iteration. You need to do 4 iteration. That is equal to the iterations, equal to the iterations are equal to the n. That means I need to do n iterations, and in every iteration you need to jump two steps, right? So yeah, I will be write pseudocode in this here. So I will be initializing I is equal to 2 here, or not 2, yeah 2. So that is a starting even number. What you can do is while um, n is greater than equal to 0, until in every operation you will be decreasing n here, and you are doing some place is equal to I, right? I will be declaring sum as 0, and in each step you can decrement the n. That would be like, let's say I will be show you that how it would be. Yeah, and every step we are jumping to two places, and you can print the sum. So this is the code how it look like. How I place 2, let's say I is equal to 2 means if I will be increase I place is equal to 2 means I will be adding 2 to the 2, right? That would be giving as I is equal to 4. I is equal to 4, I will be add, if I will add 2 I will be getting I is equal to 6, and if I will add 2 here I will be get I is equal to 8. Yeah, if you can do, you can go to the I is equal to 10 here. It's not required. Initially in every step we are decrementing n, right? So n is got decremented 1, it means that 3, and next step is 2 1 0. So we are executing in when n is less greater than equal to 0, it means it will be executing in this case also, and will be adding 8. So this is how it work, and these are the basic problems you can see, and you need to definitely solve this problem by yourself and spend time on these problems, because these problems are definitely helpful. You can take the screenshot of these problems, or you can go for the, I will be show you where you can practice their problems. You can go to the gfg here, gfg problems on loops and conditional statement. um, you can see loops and yeah, sorry. conditional statements. GeoGebra problem solution. So if you click on any of the link, you will find a lot of problems you can practice. So you can say these are the problems. These are the very basics problems you definitely solve to build your logic. In today's lecture, I think we all done all these problems except this problem. So we done this problem and all this problem. We are left with this problem because the video is going to be very lengthy. So I will be discussing this problem in the next lecture. So the next lecture would be going will be definitely on the logic building only. So in that lecture, we will be discussing the same four or five problems that are very useful to build the logics, and this is all about the today's lecture. Thank you.